Betelgeuse, a red monster star on the verge of a cosmic event, is a galactic wonder. If you put it where the Sun is, it would reach out to the orbit of Jupiter. It's huge, entirely unstable, and destined to detonate. Prepare for a vast calamity of a never-before-seen scale. Betelgeuse, the red giant star at the edge of our world, is sending alarming messages through space. Astronomers have tracked something profoundly unsettling about this colossal object using the James Webb Space Telescope. Renowned researcher Brian Cox has issued a dire warning. The pressing question is, are we about to witness a cosmic explosion that will forever change the night sky? The puzzle of Betelgeuse lies in its relationship with the vastness of the universe. Stars are born, live, and die in astonishing ways. Recently, one star has captured the attention and concern of astronomers and the general public alike. Betelgeuse, a red supergiant star in the constellation Orion. This massive and ancient star's distinct reddish hue and fluctuating brightness have long intrigued observers. Recent events, however, have heightened interest in this enormous giant. As we learn more about Betelgeuse, we stand on the brink of a potentially historic event in its life. But what do these changes in Betelgeuse mean? Are we witnessing the beginning of an extraordinary cosmic spectacle on an unimaginably grand scale? Betelgeuse's colossal size and life cycle make it a celestial marvel. It is roughly 1,000 times larger than our Sun, its size almost beyond human comprehension. Imagine a star so massive that if it replaced our Sun, its surface would extend past Mars, enveloping Mercury, Venus, Earth, and Mars in its embrace. This monstrous size not only highlights Betelgeuse's grandeur but also reflects its current stage in the stellar life cycle. As a red giant star, Betelgeuse is nearing its incredible end, expanding and cooling after depleting the hydrogen in its core and fusing helium. Betelgeuse's age is equally fascinating. Estimated to be 8 to 8.5 million years old, it is young in human terms but ancient in stellar terms. Over millions of years, Betelgeuse has undergone dramatic transformations, evolving from a hot blue star into the red giant we observe today. Now in its final stage as a red giant, Betelgeuse exemplifies how stars change over their lifetimes due to the ongoing tensions between nuclear fusion and gravity. One of Betelgeuse's most unique features is its reddish color. This hue arises from its cooler surface temperature compared to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's surface is around 3,500 Kelvin. This cooler temperature causes Betelgeuse to emit light at frequencies that make it appear red. However, this coloration reveals more than just its appearance. It provides crucial information about the star's physical state and internal processes. Historical records add to Betelgeuse's mystique. Roman and Chinese observers noted that Betelgeuse was yellow about 1,000 years ago, but by the 9th century, Arabic astronomers described it as red. This color change reflects the star's evolution and captures humanity's enduring curiosity about the cosmos. Betelgeuse's brightness is another intriguing aspect. As a semi-regular variable star, its brightness fluctuates periodically. These cycles, ranging from short 400-day periods to longer 5-year cycles, have captivated scientists and stargazers for centuries. Observations of its changing luminosity date back to Sir John Herschel in 1836. Yet, Betelgeuse's recent behavior has deviated from these established patterns, suggesting complex and poorly understood processes at work within its vast structure. In late 2019, Betelgeuse stunned the astronomical community with an extraordinary dimming event, now referred to as the Great Dimming. Once one of the brightest stars in the night sky, Betelgeuse began fading rapidly, losing light at an average rate of 0.01 magnitudes per day. By February 2020, it was at its dimmest, creating challenges for observation. This dramatic change was visible even to casual observers, highlighting Betelgeuse's unpredictable nature. Observing Betelgeuse is complicated by the time delay of its light reaching Earth. Situated approximately 725 light-years away, the light we see today left Betelgeuse nearly 1,000 years ago. This delay adds to the challenge of predicting and interpreting its behavior. Recent studies using advanced instruments like the Hubble Space Telescope have offered new insights into Betelgeuse's atmosphere. Researchers, including Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics, observed material moving from Betelgeuse's surface into its atmosphere at astonishing speeds of 200,000 miles per hour. This material formed a dust cloud that contributed to the Great Dimming. Betelgeuse's mass loss during this event was unprecedented, occurring at a rate far exceeding the Sun's typical mass loss. Scientists speculated whether this could signal an impending supernova. If Betelgeuse were to explode, it would be an extraordinary event, visible from Earth and offering a rare opportunity to study a supernova up close. Despite this speculation, the question remains, what does Betelgeuse's dimming mean for its future? Is it a harbinger of an imminent supernova, or merely a one-time anomaly in the star's long and intricate life? A few hypotheses have been proposed to explain this rapid transformation. One well-known hypothesis suggests it was a precursor stage in the cosmic explosion process, gaining momentum due to the belief that Betelgeuse is approaching the end of its life. Another common hypothesis posits that dust, possibly from the star itself, was blocking our view. It is known that Betelgeuse and other red supergiants shed material, which could gather into a dust cloud thick enough to dim the star's light. A third hypothesis examines how changes in the star's photosphere, its visible outer layer, could influence its apparent brightness. This puzzle was approached using a combination of observational techniques and in-depth analysis. Spectroscopic examinations revealed that Betelgeuse's effective temperature dropped, suggesting that the star might be dimming due to a large dark spot on its surface. The fact that Betelgeuse's temperature decreased by around 170 Kelvin during the dimming supports this idea, indicating significant changes on the star's surface. Ultimately, the Hubble Space Telescope, humanity's watchdog in space, provided critical insights into this mysterious event. Hubble's observations showed that Betelgeuse's dimming was likely caused by a massive amount of hot matter being ejected into space. This material formed a dust cloud that obscured part of the star's surface, reducing the amount of light reaching Earth. The dust cloud likely consisted of extremely hot plasma expelled from a large convection cell on the star's surface. As this plasma traveled through Betelgeuse's hot atmosphere to cooler outer layers, it formed dust grains that created the cloud, blocking light from about a quarter of the star's surface. The ejected material had a significant impact. Hubble's ultraviolet spectroscopic observations, which began in January 2019, were crucial in understanding the events leading up to Betelgeuse's dimming. These observations detected dense, hot matter moving through the star's atmosphere well before the dimming became noticeable. Ground-based telescopes also recorded the star's brightness decline in December 2019, with Hubble's findings corroborating these observations and offering additional insights into the expelled material. The discovery that Betelgeuse was losing mass at a much faster rate than previously thought highlighted the importance of this rapid mass loss in understanding stellar evolution, particularly in red supergiants. It is crucial to recognize that Betelgeuse is not the only star undergoing such dramatic changes. Historical supernovae such as SN 1054 and SN 1987A have provided valuable insights into how stars die and how new cosmic elements are formed. These events have shaped our understanding of stellar deaths and their effects on surrounding space. For example, SN 1987A, which occurred in a neighboring galaxy, offered a close-up view of a supernova and its aftermath. Such explosions contribute to the grand cosmic cycle by dispersing heavy elements and influencing star formation. If Betelgeuse ultimately becomes a supernova, it would create a spectacular light show visible from Earth. The explosion would outshine the moon and could even be seen during the day. Such an event would offer a unique opportunity to study the final phases of a massive star's life, the formation of enormous structures, and the distribution of heavy elements across the universe. Despite the dramatic nature of a supernova, the distance between Betelgeuse and Earth, approximately 725 light-years, provides a safe buffer, ensuring that the explosion is unlikely to pose a direct threat to our planet. The insights gained from observing Betelgeuse's eventual transformation will continue to advance our understanding of stellar evolution and cosmic phenomena. Red supergiants, like Betelgeuse, play a critical role in stellar development. These stars represent the final stages of a massive star's life cycle before undergoing a supernova. Their immense size and relatively short lifespans make them extraordinary laboratories for studying the end stages of stellar evolution. Red supergiants are key to understanding how massive stars evolve and the processes leading to their explosive deaths. They have a profound impact on their surroundings, releasing energy that contributes to the synthesis of heavy elements essential for the formation of planets and life. Stellar nucleosynthesis and the development of heavy elements involve fusing lighter elements into heavier ones during a star's life. Red supergiants like Betelgeuse fuse hydrogen into helium and later helium into carbon and oxygen. As the star approaches the end of its life, it attempts to fuse even heavier elements, resulting in the creation of materials like iron and nickel. These elements are then scattered into space during the supernova, enriching the interstellar medium and contributing to the formation of new stars, planets, and life. The study of red supergiants such as Betelgeuse helps researchers understand the processes that produce these critical elements and their distribution throughout the universe.